So last night we did transformations A and D, and they only affected the Y variable, or the output, and the range. Today we're going to look at the transformation of B and C, and I'm sure you can guess it. They will affect the X variable, or the input, and the domain. So you'll need to pause the video and copy down this function and this table, and then the transformation that we're going to look at today. This is going to be the C transformation. Notice the C is inside the parentheses with the X, so this would be a C transformation. If I had a B transformation, it would be multiplied by the X out here. So how does this C transformation affect my graph? Well, in essence, mathematically, what we're trying to do is we're trying to figure out what X minus 3 will give me 3. So I know this is going to be 0. What X minus 3 is going to give me 0? Well, that's going to be 3. What X minus 3 is going to give me 2? Well, that is going to be 5. What X minus 3 is going to give me 4? That's going to be 7. And lastly, what X minus 3 is going to give me 5? And that's going to be 8. And if I now plot this row, this column with this column, so this is my new X, I will get the following. I get 0, 0, 3, 0, 7, 3, nope, 5, 3, 5, negative 1, 7, 3, and 8, 0. And my new function will look like this. So you can see basically all I did was I took the purple function and I shifted it forward 3. This is called a horizontal shift to the right 3. A horizontal shift to the right 3. I also want you to see, what did we actually do? So how did I get from this negative 3 to 0? How did I get from 0 to 3? Is there a pattern here? Well, yes, the pattern is I added 3. So I want you to just notice the relationship between what it says in here with C and what I physically did to my graph. Okay, so pause and write this down, and I just want to remind you that this graph should be on actual graph paper. This should not be hand drawn. So again, with my new function, I'm taking my f and I'm taking the x and adding 5. So I'm not changing my y. So I want this y to be 0. But how do I adjust my function? So I'm looking for an x that when I add 5 will give me negative 3. And that will be negative 8. I'm looking for an x that when I add 5 will give me 0. That will be negative 5. I'm looking for an x when I add 5, it will give me 2. And that would be negative 3. I'm looking for an x that when I add 5 will give me 4, and that will be negative 1. And lastly, I'm looking for an x when I add 5, it will give me 5, and that will be 0. So again, this is my new x column. This is still my y column. I'm not affecting my y. So if I were to plot this new guy, I would be at negative 8, 0, negative 5, 0, negative 3, negative 1, negative 1, 4, and 0, 0. Okay, now let's look at this. What did I do to my purple function? I shifted it backwards. Every point shifted backwards 5. This is a horizontal shift to the left 5. Okay, so I want you to notice other things. What did I do from the negative 3 to the negative 8? I subtracted 5 from each of my x's. I subtracted 5, and in here it says add 5. This is kind of what we were talking about the other day in class about how in the parentheses with the x we always do the opposite. We added 5. So let's just look real quickly at the domain and range. We know the domain of the purple is negative 3 to 5. And the range of the purple is negative 1 to 3. With this shift, the domain went to negative 8 to 0. And the range went from negative 1 to 3. And this point should be right here. Let's make that a little better. It's not really up here. There we go, that's a little better. Okay, so again, notice the range stayed the same. So when I'm inside the parentheses with the x, I'm affecting my x, my input, and my domain. So notice I just subtract 5 here and I got to my new domain. Let's look at a couple more. So now we have, and this should really say G, shouldn't it? So let me change that to G. This should say G of x. G of x is going to equal f of 1/2 x. So remember, this is f of x. This is my parent, f of x. I'm going to create a new function called g of x that is f of 1/2 x. So we're going to do it the same way mathematically. We're going to say 1/2 times what x gives me negative 3. And this is obviously going to be negative 6. 1/2 times what number gives me 0? Well, that's obviously 0. 1/2 times what number gives me 2? 1/2 times what number gives me 4? 1/2 times what number gives me 5? Okay, so now if I go ahead and plot these, I'm going to plot again the new x and the y. So I'm going to plot 6, 0, negative 6, 0, sorry, 0, 0, 4, negative 1, 8, 3, and 10, 0. What happened to that guy? He got so totally stretched out, right? So this would be called a horizontal stretch. This is a horizontal stretch. By a factor of, now we got to figure that out. What did we multiply everything by? What did we multiply our x's by to get to our new? We multiplied it by positive 2, didn't we? So we multiplied this, all these x's by positive 2, so this would be by a factor of 2. So this would be a horizontal stretch. I stretch this out by a factor of 2. Notice my domain from for the green is going to be from -6 to 10. But my range is going to stay the same as the parent, -1 to 3. So again, this is an A transformation. Nope, that is not an A transformation. This is a B transformation. B is 1/2, but I multiplied by 2. So notice the reciprocal. Okay, last one. Let's do one that has 2 transformations. Remember, the total I could do 4 transformations, an A, a B, a C, and a D. Right now, we're just going to do a B and a C. And anything inside these parentheses, the F of inside these parentheses, will always affect my input value. It'll always affect my X. If I have a transformation out here, my A transformation and my D transformation, they will always affect my Y. So right now we're going to look at the transformation of f of -2 times x plus 1. And I'm going to do the first math outside here. So I'm looking for a number, -2 times some x plus 1 gives me -3. And I could distribute this out. And I could add that too. And I could divide by -2. So that new x is going to be 1/2. And I could do this for each of them. But I want to show you mathematically what I did to get that. So if you remember, inside here, I've had a pattern of doing everything the opposite. So I'm going to multiply by the reciprocal first. Remember, we do transformations alphabetically. So for the B transformation, I'm going to multiply by -1/2 first, and then I'm going to subtract 1. Okay, when I do the X, I always work it this way. So I know that I'm taking the X, I'm multiplying by -1/2, and then I'm subtracting 1. So let's look slowly at what happens to the 0. I'm going to multiply 0 by -1/2, and I'm going to get 0, and then I'm going to subtract 1. I'm multiplying the 2 by -1/2, and then I'm subtracting 1. I'm multiplying 4 by -1/2, and I'm subtracting 1. I'm multiplying 5 by -1/2, and subtracting 1. So the column I'm going to graph are these x's and these y's. So I'm doing the outermost x's and the y's. So I'm going to graph 1/2, 0. I'm going to graph -1, 0. I'm going to graph -2, -1. I'm going to graph -3, 3. And graph -3.5, 0. And I end up, wow, what happened to that? It looked like it got squished and moved to the left. But it also looks like something else happened. Do you notice that whereas I have a line and then a hump, I now have a hump and then a line? What happened from here to here? So the first thing that happened was it was reflected over the x-axis, over the y-axis. Nope. Y-axis. The second thing that happened was I had a horizontal compression. By a factor of, what did I multiply by? 1/2. We'll talk about why it's not -1/2 in a minute. I also had a horizontal shift left 2. Sorry that's so squishy. Make sure it's spread out in your notes. So, why is this not by a factor of 1/2? Well, what reflected me over the y was the negative. The negative always reflects. As soon as I see a negative here or a negative with a, when I multiply by a negative, inside here is going to reflect me over the y-axis, if you remember that a reflects me over the x-axis. So the negative is what reflected me over the y-axis. This is what did my compression. This is what did my shift. Okay, so that's all for today, and I will see you tomorrow.